Keep trying. Messed up in the other class too. Hi, yeah. So the other guy, he's out cold over there. I'll show you at the end of the lesson. Let's see what's going on. Okay, so we're gonna do factoring special cases part 2. 14, 16, and 22 off of yesterday's worksheet, so hopefully you still have that. And you can take a look at these 3 problems. You can try 3 more. You can try as many as you want to complete the worksheet. That's up to you, but 3 would be minimum in my book. Yeah. All right, let's do number 14. Special cases. Special. What makes you so special? Well, I see this 100 right here, and I think perfect square. 10 times 10. I see the 81. That's also a perfect square. 9 times 9. So I think the right approach might be to take a chance on guess and check and see if the middle can work out. Maybe you don't see, like you're like, where did the 180 come from? Well, take a chance. When you see this, okay, the 100 and the 81, split this up into 10x times 10x, right here. And then take the 81 and do 9 times 9, there, and there. And plus plus here, plus plus there. Here, plus there, plus everywhere, plus plus. And now does the middle balance? That's what we're looking for, okay? So if you multiply the outer, which is here, that's 9 times 10, that's 90, okay? 90x. If you do the inner, that's also 90x. And if you add those 2 terms together, you get the magical 180 in the middle. So this is the correct factorization of that trinomial. And it's special because these binomials are the same. So I say we go ahead and write this as 10x plus 9 squared. Looks a little silly kind of being too far away from the 10. That's better. Okay. We have factored the trinomial. Let's try again. Special. Special. Is this special? Is 49 a special number? Yeah, it's 7 times 7. 16. 4 times 4. Okay, so when you see this, and this number doesn't make sense yet, take a chance on these 2, since they're perfect squares. Just kind of like autofill with 7 and 7. Don't forget the ends on those, those will be important. And then 4 and 4. And now think of your signs. If it's minus plus, do you know the sign rule yet? It has to be minus minus. Because the only way to get 2 numbers to multiply to a positive and add to a negative is with 2 negatives. Okay. Now, did this work out? Well, what's the outer term? That's negative 28n. And the inner term is exactly the same. See that? That's negative 28n. Or sorry, n, sorry. And if you combine those 2 terms, you get negative 56 in the middle. So that is correct. And we need to write it as a binomial squared. 7n minus 4 squared. Okay. So I'm hoping you're picking up on what makes these special, perfect square elements, and also the fact that they end up like this, or there's the difference of 2 perfect squares, which I might have to throw one of those in there real quick because I noticed now that I didn't actually put one on there. All right, number 22. Something you always need to look for is yeehaw factoring out GCF. Okay. Back here, 49 and 16 don't have any common factors, so you couldn't do it. 100 and 180 share a factor of, what, 20? You know? So that could have worked, but that is not a common factor of 81. So there was nothing consistent in all 3. But that's not true here. Oh, gotta finish it. What is the GCF of 280 and 8? Okay. Now, it's got to be a common factor, so start with the smallest one. 8 only has 4 factors. 1, 2, 4, and 8. Does 8 go into 200? We'll start with that. I think it does. 8. 8 times 25. Yeah, 8 times 25. And then 8 obviously goes into 80. Now look at all 3 again, and notice that they have not just 1, but 2 m's that they share, or m squared. So you're going to rope out an 8m squared, okay? And you're going to divide each term by 8m squared. I would prefer that you set it up like this. I think that's a good thing to do. And then write the GCF out front. Just because you factored it out doesn't mean you can forget about it. It has to remain in the expression. All right, let's do some, exponent work. Divide 200 by 8. I've already done that in my mind. It's 25. And then subtract with the product rule to get m squared. Divide these two and get 10. And then subtract the exponents with the quotient. Did I say product rule? I meant quotient rule back here. Sorry. It's hard when you guys can't correct me. There's nobody here but me. Subtract with the quotient rule and get 10m. And then the last term, you guys notice, is a 1. Okay? Because if you divide something by itself, it's a 1. We're not done yet. All you've done is factor out the GCF. Now, is that special? Yes, it is. 25. 5 times 5. Is 1 special? Oh, for sure. It's also the loneliest number. But it's special. It's 1 times 1. So with the 8m squared in its place, just write it down. You're going to now take a chance on 25 being 5 times 5, because it's a perfect square. On 1 being 1 times 1, because it's a perfect square. Plus plus here, plus plus there. And do we get the magical 10 in the middle is the question. Well, if you balance the outer term, which is 5m, with the inner term when you multiply, also 5m, yeah, 5m and 5m adds up to 10. You're golden right here. But this needs to be written just like we wrote it back here and back on the first one as a binomial squared. So 8m squared times 5m plus 1 to the second power. Now the only thing I didn't do, like I said, is the difference of two perfect squares. I can add that in just about anywhere right now. So if you see a perfect square subtracting another perfect square, like that, then it's exactly the same binomial with a plus and a minus, okay? So this would be factored into 7n and 7n. Take a chance on that. I'm sorry, 4 and 4. 4, oh my goodness. 2 and 2. 7 and 7, plus minus. That gets the middle term to cancel because this is a binomial, these are trinomials, these have these middle numbers, right? This one doesn't because it canceled out because you have the same thing with a plus and minus. All right. All right, so now I just need to show you what happened with that guy. So let's rewind the tape. Okay.
All right, here we go. Come on, you got this, Strick. Okay, maybe you don't, but that's all right. Confidence. Ooh, what is it? We'll try a fastball. Here we go, fastball. Wait a minute. That's the music from last time.
No.
I don't blame you. I wouldn't want to go with that music either. Maybe I'll switch to a curveball.
Okay.
Mini-Me's not over there, so he's not going to give it away this time. All right, curveball. Here we go. Ha! Fouled it off.
Fouled it off.
Come on, Q. You're better than that. What are you doing swinging at a first pitch curveball? Man, just think about how awesome you are. I am awesome. Yeah. Look at that guy over there. He ain't that good. We got this. Dingers. All right, Strick. He fouled off the curveball. Let's go high heat. Oh, that's different music. Oh, I like it. I got a chance. Here we go. Gone.
Not this time.
See ya. And now you're unconscious.
Okay. I'll do the next one since I think he's in a coma. So, yeah. Let's go ahead and zero it out. There's green all over the classroom. Oh, so I did marker toss. Watch out! First time I missed. Well, since you've been here. Have a good Tuesday.